everybody, this is Johnny B. Here is my CNC machine I built about, say, 5 years ago. I haven't really taken the time to improve it, so today I'm trying to change the motors out. I have steppers. I currently have stepper motors. Here's one of the stepper motors. It goes on to a belt. That's the belt system, the pulley system is about a 7.2 to 1 ratio, so makes it really slow, but accurate. So the design uses 2 ball screws for the y-axis, one for the x-axis. Again, still stepper motors, and more stepper motors over here on top, as you can see. I designed this CNC machine. You can do about 4 feet, I think, of cutting area, and 40 inches on the y-axis. I think so, 48 by 44 maybe. I think that's what it is, if I remember correctly. But as you can see, I have it set up to be able to do plasma cutting and CNC routing. Anyway, let me run a program here, anything, just to show how the CNC machine works or moves. Here, plasma cutter's off, but say this what I just cut, and let's do a trial run and let it run the CNC. Right there, I'm going to hit go, and the CNC should go if it is plugged in. I'm going to plug in the power source. It's hard to do. Hear that crackling? That shouldn't happen, but I was using one hand on the camera. Anyway, let's just say let's set X to 0 on my laptop. Focus there. Z to 0, and just run this program. So, as you can see, just running. That's traveling around 47 inches per minute. Not the fastest, really. Turns out it's just fine for 3/16 of an inch when we're plasma cutting. So Z, and that's supposed to be the end of the program. What I'm going to do next is turn off the camera and actually cut something. First cut we're going to do today is we're going to try to cut this simple pattern right here, and I'll show you in a minute what that does for us. But first we gotta set the machine to its 0 axis origin. I'm thinking just zero it out. Just inch into it. Okay, that's 0. Bring up Z. I'm not quite sure this is straight, so I'm going to move this over. It's actually heavy. It's hard to do with one hand. Okay. There we go. So, let's set up the origin, XY origin. Oops. Well, at least my limit switches worked. It stopped the machine from going forward, so I guess I gotta push back my 3/16 plate right here. See, it's resting on this thing I just made. Those were test cuts I've been making. See how well I can make small circular cuts. So I just moved back the plate. Now we'll do that again. I want to go down. Y. Oops. I meant to move in the Z direction there. So, looking at it, focus, focus, focus. I need to go to the left a little bit. X. And Y. I'm guessing that's about right. And that's about right. I think we got the tip. Just doing a dry run here. I always like to, well, if I got the time, do a dry run, see if the torch doesn't have any hang-ups. Especially since it's just a small cut. Alright. That's it. Oh. Yeah, it's cutting. This is the reason why I do a run. See how it was just cutting at the edge? Oh, two things I found out. I need to move my origin a little bit further back. So this needs to go that way. That way. And I think my torch is not totally straight, so it's just riding on a magnetic base here that I've manufactured again a few years back. Not really the prettiest, but I just made it out of aluminum, milled it using the same machine with this right here. Oops. Chinese spindle and the CNC gantry. And I think we're set. Just need to move back the Y axis. So I'm gonna move back here and put it on the camera. So all I'm gonna do is just tab it and be set. Do another dry run. Helicopter overhead. That's the noise. So those are the slots. It's cutting. Just move it over here, make sure it's in line. Yeah, it tells me I gotta move to the right some. That's what it is. That should do it. I hate wasting material, but sometimes you got to. You got to. All right. So I think we're all set up here. This, I think I got my X and Y and Z axis is straight on the machine, program right. And again, we're trying to cut this part right here. And I'm gonna get my welding helmet, and right before I hit the button, right before I want to hit the button, I realized I didn't put my ground clamp on. So that should do it. Nice ground. Let's turn on the machine. Okay, it's set up. Now, I think we really can do it this time. I'm gonna hit go and let the machine have at it. Well, that's what it turned out. It's getting dark here, so I don't have much light. I'll take the pliers, get my pliers here, and just see what we got. Let's go back here. There's a little bit of light, and see how we did. Some slag there I can knock off with a hammer. And a lot more slag in the back. Overall, not too bad. So we're done cutting this part. And I forgot to show you really what I'm trying to do here. I'm trying to make this mount right here for my new servo motors. I want to replace those stepper motors. As you can see, the idea is the motor mounts on these 4 screws, right? 4 holes here, mounts onto some bolts and nuts. And because it's belt driven, I need to be able to tighten the belt. So I have these slots here so I can push down or up on the motor and tighten the belt. I had it before in the stepper motor. I had just cut. See some slots over there. You can tell the slots right here. I know it's getting dark. I don't like that. I didn't like this. I just use a tube. And as you can see, I cut this. See how jagged that is? That's because I just cut it off with my plasma cutter by hand. Using the CNC. I didn't have the CNC back then, so it's much better having a CNC machine. Get this, make these work. The next part I'm going to cut is this. This is the front of the motor mount. And if we open it up here in SolidWorks, that's this piece right here. You can see. And I'm going to open up sheet cam. Sheet cam right here. Do the post process. I already done the edits. Okay. Go to my CNC software. I'm gonna reload it. File. Import G code. Why servo mount front? Next part I'm going to cut again is the front, but this time we're going to, instead of doing a single pass, we're going to do it in two sequences, because I find that if you're cutting small circles, plasma cutter just I can't, at least I can't get my plasma cutter cut really clean. So in this case I'm going to lower the feed rate to 10 inches per minute, cutting small circles here, I think 0.21 inch diameter, so real small, smaller than a quarter of an inch. And I find that I've done some test cuts. Actually, I can show you right here. I've done some test cuts, the different cuts I've made. Let me move over here to the light. Again, I'm just doing this in my garage, so I've done different test cuts, and I lowered the speed. I think I went as low as 6 inches per minute, all the way up to 46 inches per minute, and these are bigger holes. I have another. As you can see. All depends. The slower you go, the bigger the hole. Faster you go, smaller hole. Sometimes not even enough of a hole for you to put in whatever it is you need to put in. In this case, I'm trying to put in a bolt through. Here's what I wanted to show you earlier. These right here are about my attempt at making 0.21 inch holes. And I went as low as 6 inches per minute, all the way up to, I think, 40. And what I found was really 10 inches per minute. And it works for my machine, for my millimeter spectrum Extreme 625 and 3/16 of an inch. Again, the whole reason why I'm doing this is so I can, I'm changing the motor outs, are so I can get better acceleration, hopefully get better cuts for my plasma, and also better accuracy if I ever need to cut wood or other things, mill other things. Here's what I wanted to show you earlier. These right here are about my attempt at making 0.21 inch holes. And I went as low as 6 inches per minute, all the way up to, I think, 40. And what I found was really 10 inches per minute. And it works for my machine, for my millimeter spectrum Extreme 625 and 3/16 of an inch. Again, the whole reason why I'm doing this is so I can, I'm changing the motor outs, are so I can get better acceleration, hopefully get better cuts for my plasma, and also better accuracy if I ever need to cut wood or other things, mill other things. Again, turn on the machine. Oh, maybe not. Let's do a test run of the other file. Make sure there's no problems with that. Import G-code to open, and do a test run on this one. That's it, cutting the circle. That's the circle right there. And the point of doing this is so we don't waste material. Waste a little bit of electricity, but see here, right there? See how close that is to the edge? And here's the other thing. You hear those relays popping, turning on the machine on and off. Okay. So all in all, I think that's good. Hopefully that's better. That's all the cuts I made today. Yeah, a lot of slotting. Again, 3/16 of an inch thick. Come on, focus, focus, focus. Quality of the cut. You see the slots. There they are. Again, still some slack. Well, all that's left is for me to weld it up tomorrow. Hopefully, I'll see you then.